As I'm sure we are all aware, the new Ontario math curriculum has included some new expectations, particularly in the area of coding. And so the series of videos that we are going to be creating is to help all of us understand, first of all, what the expectations are, but more importantly, give you some examples and some templates to be able to work off of. While we recognize that there may be students and parents who are going to be watching these videos as well, these videos are really designed for educators, primary educators in grades 1 through 8, who are trying to understand and want to start developing some coding activities within their classes. And so with the help of our St. Emily Coding Club student ambassadors, we're going to give you some examples that hopefully will start the conversation as to what are the types of things that you can do. To begin with, though, it's important to understand what the expectations actually are, and you will notice for each grade, there's generally two. The first one starts off and it says solve problems and create computational representations of mathematical situations by writing and executing code, including code that involves sequential events. And when you go through the grades, you quickly discover this first expectation, the only thing that ever changes is they're going to add a second and third and fourth and fifth and so on event. The wording is exactly the same. In grade 2, it says the same thing, except it says that involves sequential and concurrent events. And in grade 3, it says sequential, concurrent, and repeating events. And so when we take a look at that and we go down to the teacher supports and the key concepts, you'll also notice that they give us a little more clues as to what this could possibly look like. And the key thing to remember here is it does not require access to technology necessarily. If we look at it, coding can support students in developing a deeper understanding of mathematical concepts. It can include a combination of pseudocode, block-based coding programs, and text-based coding programs. And this is really key. And our student ambassadors and myself are going to show you all three aspects here. Pseudocode is more in terms of that physical representation or even paper and pencil. Block-based coding programs, probably the best well-known one is Scratch 3.0. And in this particular case, for our text-based coding programs, we're going to use the Logo language and Lynx Coding, which is the intermediate level of the Scratch program as well, and free to all Canadians with a school account. It also says that students can program for various agents, such as a pixelated image on a screen, a classmate acting out the code when appropriate, or a physical device. And so this is where they give us that caveat of it does not necessarily have to be done through technology, but rather it can be done using a picture on a piece of paper, or it can be done through a physical representation of some type. The second code that we have second expectation we have is read and alter existing code, including code that involves sequential events, and describe how changes to the code affect the outcomes. And this is why we really wanted to give you some examples and some templates to be able to work off of, because you can hopefully take these videos and even have a discussion that if you were to change, for example, one aspect of the block in the Scratch coding for the sequential event that you're about to see, how would that change what you would end up getting? And so it's that prediction aspect, and it's altering that code and predicting what we think the effect is going to be. And so I hope you enjoy this series of videos. Because there are 8 grades, it will be a series of 8 videos. And the first one that you're going to watch is the grade 1 expectation. Now, when we think about sequential coding, the key thing to remember here is sequential coding is essentially when we're going in order. We can actually use a number line to signify this, and we can create some coding off of that, which I'm going to show you a little bit later. But one of the exercises that we could do, even if you don't have a coding program to work off of, is something as simple as a connect the dot exercise, as you can see here, because we are still looking at sequence. And the main thing that the expectation wants us to understand is the fact that we can skip over sections, but what we can't do is change the order. And by changing the order, we're changing the expectation, whereas if we are skipping, we're still maintaining that sequence. And so what we mean by that is simply this. As you can see, I can draw my line, and I am now sequentially coding. I can go to my next line. I can continue on through here, continue on through here. If I wanted to skip where I'm going from E down to G, I'm still fine. Same thing and same thing. But at this point, if I wanted to, for example, start jumping around where I'm not following the sequence, if I, for example, decided to go from the I to the D, and then go from the D down to the M, and the M down to the W, and over to the Q, it's not working anymore. And that's really what sequential coding is all about, is recognizing we have to maintain that sequence. You'll notice within the expectation, though, that it does not necessarily say numbers. And so that's why I actually wanted to do this connect the dot using letters. We can actually physically do this. And in fact, if you think about in grade 1, how do we maintain, how do we work through the hallways? And in fact, particularly during COVID time, we want to make sure that every student stays in their place within their line as they are going through the hallways. And we're teaching them sequential coding. And in fact, you could even evaluate based on that expectation. How well do they stay in line as they're walking through the hallway? So, and that's a physical representation of sequential coding as well. So hopefully that gives you a bit of an idea. I'm going to turn it over to our student ambassadors. So thank you for joining us, and stay tuned as they come on next.
Okay, so what I did with this one is, so I took one flag clicked from events, then I went down to, you can't really see it right now, but there's these two, it went down to here. Actually there'll be these two bricks. That's where you can find this. I put, set pen color so I can change the color whenever I want. Then I put erase all, then pen down so I draw, and then I did a whole bunch of different point and direction moves. And hi everyone, today I would like to present my Scratch project called Connect the Dots. So, Mr. Moore asked me to do this. The point is, so I placed 26 balls from A to Z, as you can see. And then I coded it so that when ball B moves as many steps as it needs to move to ball C. Then that triggers a chain reaction, which lets ball C move to ball D, and so on. So here's how it works. It does that, and the coding behind it, like this. I did one green flag clicked, set pen color to red, and pen down. Then it points towards ball 3 and moves distance to ball 3 steps. You can see, and I did the same thing for ball 3, except I said wait until touching ball 2 right here. Then so on and so forth. And then finally for the ball 26, I did this. Alright, thank you for listening.
Here we have a program where we're going to connect the dots on this dinosaur. Alright, let's run it. You see? Alright, I'm going to show you how it works. So to make the when the turtle moves, it creates a line. In order to do that, we're going to use the pen down command, or its short form PD. And to make the turtle turn, we're going to use the set heading command. Here I set it 305, and then we're going to use the forward command. Forward 20 works best, or you can use a short form FD. And then you don't have to do this, but I use the wait command to just give a little time before it makes the next move. And then you repeat that sequence over and over again, just modifying what direction you're turning in. And that's really all.